Okay, we are recording the second lecture in English for Iraqi students. As we have in the Farsi lecture, we covered history of neural network. I will briefly go over these materials and then you have to read these carefully, and if you have any question, return it to me. In 1940s, neural networks went to calculate arithmetic and logic function as using the McCulloch-Pitts basic model of a neural network. Then in 1950s, perceptron was introduced. 1960s, adaptive neural network were introduced. And in 1980s, the propagation algorithm for the training of neural network was introduced by Rumblehartz. The reasons for using neural network. Why neural networks? What fields? In many fields, you can choose your work to study. You can choose your classwork. You can choose your class project for pattern classification, signal processing, modeling and control, optimization, expert system and fuzzy system, and even for financial problems, insurance, security issues, stock marketing. So you have a wide variety of applications of neural network that you could choose them for your classwork. So neural network basically depends on neurons. We have three parts of a neuron are called cell body, dendrites and axon. You can see this is a neuron structure as you like. We have a dendrites, we have nucleus and axon. A signal propagates from the dendrites to the nucleus. And you can see the propagation of these signals through the axon going toward the other neurons. Of course, the signals are received from dendrites. At the synaptic weights, they get their own weights, and with respect to the threshold of these neurons, these neurons can fire and send the signal to the others. So artificial neuron has input signal, weights, and activation function. This is a McCulloch-Pitts model that the activation functions, the output of the neuron depends on the input, which with respect to the stepwise transfer function it is used. This is again a biological neuron, and we are going to compare in this case these are the activation functions as step functions, sign functions, sigmoidal functions. This is how you compare a real neurons with a artificial neuron. A real neuron, and you can see dendrites are the inputs, synaptic weights are the weights, summation at the cell body, which is the sigma WIXI, and O, the output of the neuron with respect to the threshold unit is equals to 1 if this summation is greater than 0, and otherwise it would be equals to 0. And you can read these through, and the same story here for showing a unit. A single neuron would be represented as a single unit with the input values, weights, adjusted weights, bias, summation, and activation function, which would generate the output of the neuron. And here we have shown y, which is f(h) of sigma WIXI plus WB. If you have only two inputs here, we are showing if we have two inputs, input 0 and input 1, y would be equals to u of W0x0 plus W1x1 plus WB, where WI randomly is chosen as the initial weights to be -1 and 1. Then you have to train these networks. Here clearly we are comparing these two categories of physical neuron as a real neuron, and this is a biological neuron, artificial neuron. You can see this is a artificial neurons. Inputs, variable weights, summation, and the net, which you can add the input weighted values and find the output with respect to the transfer function, activation function. Again, showing inputs, weights, summation, activation, and the output. These are the five variables of a single neural network, single mathematical model of these neurons. To calculate and to train a neural network for a single perceptron, you have to find the error at the output, which is the difference between the target and the output. And using this learning rate, you can choose these, find the error and find the adjusted weight and new weights. Therefore, with respect to this, you can have, of course, a mathematical representation for these transfer function as hard limit transfer function. In MATLAB orders, you would show it as A equals to hard limit, and for linear transfer function you have pure line, and for logistic and radial based function. These are the transfer functions originally used. So let's represent a single layer fed forward neural network as an input layer and one layer of each 4 nodes or some nodes, which are the single layer fed forward neural network. This is a multi-layer fed forward neural network, input layer, hidden layer, and we have shown 2 neurons at the output. So this network is called 342. 3 neurons at the input layer, 3 signals we will receive from the environment of the inputs, and 4 hidden units and 2 neurons at the output. Let's of course show you the structures of the neural networks, which they could be fed-forward networks, they could be recurrent neural network. Fed-forward network, they are introduced as single-layer perceptron and multi-layer perceptron. And for recurrent neural networks, we would have self-organizing map, Hopfield net, and ART model. This is showing you clearly what is a fed-forward network, a perceptron, a multi-layer perceptron. It is called as the inputs, hidden layers, and outputs. So to classify these 2 classes of inputs which are not linearly separable, you need more than one single unit. You need here 4 equations. You need 4 neurons in a hidden layer to classify the 2 classes of inputs that are not linearly separable. If these 2 classes are linearly separable, you can use a single unit neural network, which is this is the decision boundary, which is the surface that dividing these 2 classes of positive from negative. But here they are not linearly separable. They cannot solve this with a single unit neural network. Therefore, for AND or OR function, it is clearly shown that you can solve this problem, AND problem and OR problem, using what? Using a single neural network. Here showing you how to learn Boolean AND. We have 4 examples, 4 conditions for 2 variables, x1, x2, where output is either 0 for these 3 conditions, and only when both x1 and x2 are equals to 1, the output would be 1. This is the AND function. Therefore, you can see, using a single unit neural network with 2 inputs and 1 bias, we can solve this problem. We can learn AND problem using a single layer neural network. Same thing goes for NOR, But for XOR, you're not able to solve this problem. You need a surface to classify these four. Single neural network can learn to divide, to classify two classes of vectors from each other, which are divided into two areas. For example, this is a network of two inputs, P1, P2, and the output would be A. So this is a decision boundary. WTP plus B equals to 0. For the example of OR, what are the training inputs? P1, target is 0, P2, target is 1, P3, 1, 0, showing here, target is 1, P4 also 1. So we have 3 1s and 1 0. You need a decision boundary to solve this. So to solve OR problem, this would be our decision boundary. This is an equation of a line with respect to, of course, you can choose the initial weights to be half for each of them, and based on this equation, you can find the bias to be equals to minus 0.25. And now multiple neuron perceptron with respect to this equation can classify input vectors into two categories, but a multi-neuron perceptron can classify input vectors into 2 to the s categories. So we have a hyperplane here. We have a plane here that divides the area into two. This would divide the area into two sections, but here using a multi-layer perceptron, I did show you here, a multi-layer perceptron can divide, you see, it can divide to many sections and can classify any non-linear problem. This is an example. You would go over this example, of course, how this example works. I did explain it in the Farsi class. And this is, of course, showing you a surface using to classify XOR problem. We need a surface. We need more than one. For AND operator, show this. For OR operator, linearly separable. NOT operator, they are, it's shown here, they're all linearly separable. So you can use a single neural network, single unit neural network, single layer neural network to classify this. They're all linearly separable. But XOR, since it is impossible to draw a line, divide the two regions containing zeros or one, the XOR operator is not linearly separable. So this is a problem for dividing, sorting apple and banana, that we will record it in next as an example. Go over this problem as well. We have apples and bananas. This is a system neural network to decide to sort these two. We will decide to have two prototypes, one for the banana, one for the apple, and these would be three variables. You see, if the shape could be round or elliptical, texture could be smooth or rough, weight could be less than 1 pound or greater than 1 pound, and we would have two samples for banana and apple, three variables, and based on these inputs, we can design a neural network, set the training set to learn this, and this would be able, this neural network can learn to sort banana. You can see it can sort, if you will test, this is a banana, this is an apple, and this is also a banana. So this is a neural network. For neural network contains input layer where each node represents one predictable variable. The node in a hidden layer can be linked to the node in another hidden layer, and the output layer contains one or more output. This is a decision. This is the part